Spectre, you got first, like usual. You're just cleaning house. Bob, yep. I mean, I should have updated the tag right after we finished, but I didn't think to, so I updated last night. I'm sad to see it go. Okay, but you know, we had a game. I respect the result, so YouTube stream is working. Looks like it. Okay. See what my DM is. Oh yeah, there's this limit here. It's like they got what they need. Okay. I was reading my old response. Let's go look for a new question. Okay. We're displaying the reasoning behind the steps highlighted. The top red arrow, step 1. The middle, step 2. There's only 2 red arrows. Where's the middle one? I assume they mean the line between those two, though. How did 8 turn into 4? Okay. And how did it transition from step 2 to 3? Okay. Oh, I can't even zoom in on this one if I wanted. Someone else wait, I saw it too. Alkalaner got it. Alkalaner is very quick on these. And we do run out of questions. We do have a good amount of real analysis that we can do, so I'm not worried. What is EMI? Oh, electromagnetism? I don't know why I feel compelled to click on it anyway. Oh god. What? Sketch the variation of magnetic flux, the induced current. Huh. I definitely do not remember how to do this stuff. I feel like I could have if I was still in my Physics 2 class, but it's been so long that I don't remember those. On one hand, calculus-based physics for electromagnetism was among the hardest classes that I have taken. But I kind of wish that now that I have Calc 3 knowledge, because I didn't then when I took it, that I could retake that class, because I think I'd find it kind of interesting. But up until that point, I'd only taken like Calculus 2, which is like difficult integrals and power series, which you can still do a lot with that, but multivariable calculus stuff helped improve my understanding of what that stuff is saying. This looks like some linear algebra stuff. Woohoo! Hello to you? What the heck? Oh, was this not rotated the way that things are usually rotated? I guess not. Okay. The transformations are performed repeatedly. Matrices spiral around and are attracted to a fixed... Oh. I'm doing good too. A little tired today, but it happens. The attractor of a matrix. I had never heard of it in an attractor. How's class? It was good. It was a lot of calculations. I ended up having to do a bunch of fraction math, but we went over some interesting stuff once we did get past those calculations, though. So I'm likely going to revisit the ones that we didn't cover in class as well. Later on stream. Oh, did I learn this in a different context? This is eigenvalues and eigenvectors? Is that it? No, it sounds like spiraling. Ooh. This is some fun stuff. And so it looks like so I learned it in the context of differential equations, like what's happening here. And it makes complete sense, but I never thought about how some of the techniques that we were using are generally applicable and not only applicable to these differential equations. Like you don't have to only consider it, or maybe you do. I don't know. But I haven't done it really with a matrix like that. I don't really know what it means to do it with a matrix like that. So I think I might move on because this is a little too far away from stuff that I remember. I'm sure I could figure this out, but it's going to take me a lot of and umming and Googling and oh, actually, like wrote out some of the transformations that happen. I think I'm just going to leave it. It's grade 11 pre-calc? That is not... What kind of genius students are doing that stuff in grade 11 pre-calc? Oh my gosh. I was doing that in the last year of my math degree. You probably distill it and, like, you know, explain it in an easier context, but, like, God, that's we were, like, factoring quadratics, and students were still complaining about that, even. Let's go over to learn math. I'm okay. Yo, Ben, how's it going? How's my linear algebra? Not very good. I'm comfortable enough with the matrix operations. If it gets a little too proofy, then I'm not too good with it. Not proof stuff? Okay. Like it's all right. If you have something, feel free to send me. You might a bit later. Okay, sounds good. Um. All right, I'm not putting a whole ton out on Reddit. Honestly, I'm kind of excited to do the real analysis stuff, so maybe I'll just go right over to that. Because I really hate hunting through the internet for questions, to be honest, and if I can't find any, it just gets lame. So let's just do some real analysis stuff. You should scooch over, right? Oh no, but then there's a gap. Oh no. It's going to annoy me. That's about right. Okay, good. So let me actually bring up the notes that we took in class. So I think I'm going to start with that parabola one. Oh, you know what? No, we're going to start with this one. I thought we had already done this one, but we actually skipped this one. And I want to look into what this actually seems like, what this actually is going to come out to be. I still want to see our notes for this, though, because we worked through question 1, which is very related to question 2, but we're taking a particular case of question 2, basically, and doing the calculations with that. And then question 2 asks us to generalize it for any line given bounds alpha to beta. So let me, the area, it's too much. The part in particular we want, I guess I want to generalize is this line right here. So these are Darboux sums, which were a new concept for me, but if you know Riemann sum, it's just a slightly different version of that. Where a Riemann sum, you always take the left or right end or the middle of each interval. With the Darboux sum, you can take an upper Darboux sum, which is taking the maximum over each subinterval, or a lower Darboux sum, which is the infimum of each subinterval. So very similar to Riemann sum, but you're a bit more flexible on where in the interval you draw your rectangle. I bet this also has some nicer properties with you're guaranteed that an upper Darboux sum is an overestimate and the lower one is an underestimate. Or exactly right if it's a constant function, I guess. Whereas with the Riemann sum, it kind of depends on whether their function is increasing or decreasing, which one is over or an underestimate. And sometimes you just don't know. I guess you might still not know with the Darboux sum though. If it's like increasing and decreasing, you don't know like where the error is the most or least. Okay. So down here in question 2, we're taking the upper Darboux sum minus the lower Darboux sum for the general case of a line. Okay, let me just finish my tea quick. All right, let me put my mug away and then we'll get into it. Okay. Okay, so we want from alpha to beta upper mx dx minus lower alpha to beta mx dx. So let's start by looking at the upper sum, I guess. So the upper sum is going to be our delta x, which we can factor out from the summation, and delta x, well, you can write the kind of general formula. Now, how we're going to index it? I index starting from 1, but I think maybe to be proper, or it's not to say improper, but I think it's good form if we match the definition of a Darboux sum we were given, which starts from 0. And I was just scrolling up to make sure that was right. So I equals 0 to n. Well, that's in the ith sub interval, I guess. So let's we're gonna have to unpack this a bit. Delta x, we have a formula for. It's going to be n point minus beginning point over n. This, since we're taking the upper sum and this is a line, well, we need to consider, we actually have two cases for a line. One where m is positive, one where m is negative, and one where m is 0, I guess. Well, for m equals 0, you don't have any vertical translation here. So your area is 0. I guess we should think about what happens with different values of m, because if you have m greater than 0, your upper Darboux sum is going to be like a right-handed Riemann sum. Actually, I guess it's kind of, we need to consider negative bounds as well, because that's going to be kind of the same issue. So I assume the numbers are still going to work out, but I don't know that, so we should think about it, I guess, because like coming over to the negative areas, the supremum for like this first one, we're going to say is 0, I guess. And becomes like a underestimate, kind of funny. So how do we, like, in positive it's an overestimate, in the negative it's an underestimate. Which I don't really think about it until just now. So how can we deal with that? Or how can we engineer a method so hopefully that doesn't even matter? That'd be ideal, I guess. So maybe let's try making a formula and testing it. So we said the supremum, maybe let's take the formula I made for like the positive cases here. Sappy the cool kid, hey, welcome in. I'm just doing some like study questions, but if you have a question for me, please let me know. I'm gonna mess up the browser for a second here because I want to review the work that I did. Okay. So here for theta supremum, we take our same m, and instead of x, we need to calculate, we need to split up the interval into n many sub-intervals and take things at equal parts of that. So let me explain what this does. So this should be I plus 1 over n for an upper. Well, we need to answer that question, I guess. Well, though, then that'll mess up the endpoint. Maybe I equals 1 is just the right answer. Or maybe we just let I be 0, and we just know that this entire thing is 0? No, the entire thing is not 0. We got parkour happening? Hey, Thunder. Rare Thunder jump scare? Yeah. Welcome in, Thunder. So maybe I will do it the way that I did it during class. I think I equals 1 is just easier. But we need to make sure this actually works, right? So let's like try alpha is -4, beta is +4, n is 8. So that way we just get actually, why do I use such big numbers? -2 to 2 is fine in less rating. To give us some nice, like, clean numbers to work with here. Actually, should n be 5? No. N equals 4 is fine. Because we only, in class, we did, our examples from +1 to +4, so we didn't really have to worry about the negative numbers, but it seems like we do have to worry about it. I don't know why I erased that. That's perfectly fine to have that there. M greater than 0. Okay, so with this thing here, our first iteration is going to be m times 1 over 4. Beta minus alpha is 4, plus our starting point is -2. So that is going to be our starting point plus 1 becomes +1. And that actually lines up perfectly because our first subinterval is from -2 to -1. And for an upper Darboson, we would want the right side of that, which is going to be the -1. So I think that works out fine. in the case for a negative slope, well, don't things get flipped with a negative slope? Because then we want the left side of the interval, don't we? I'm not really drawing this accurate to the example that I made, but I drew this terribly. You had a test with a question similar to the Poisson distribution question you asked, and you got the highest in your class? Nice! I hope you got that particular question right as well. I'd feel even better, but as long as you got the highest score in your class, that's great news. Congratulations. So I think this breaks down if our slope is less than 0, because if our slope is less than 0, we would want to take the negative 2 and this gives us negative 1. So do we need to split up our calculations based on m? Like one case for m greater than 0, one case for m less than 0? I think that's the solution here. Or that's the thing we have to do. I don't know how we're gonna fix it for that though. So we can say m is greater than 0 here. But how do we do the m less than 0 case? Oh, it becomes like a left-handed. Do we do from... Maybe I should just start from I equals 0. How does this change though? Well, no, we do. If we have n many subintervals, we do want to start from I equals 1, I guess. This is there a little inconsistency in the definition, maybe? Let me, So so not necessarily an inconsistency, it's just a little kind of funky thing where if your sum is from I equals 0 to n, you actually have n plus 1 many subintervals, I think. So there's nothing inconsistent about this, it's just a little bit unintuitive. And so if you're going to be like me and just say from I equals 1 to n, I think I'm also right. Because we're just taking a slightly modified definition, but it's not... a significant difference. But if I can, like, can I make this match it more exactly though? Like, if we set from I equals 0, how does this change? Or how should it make it? Might be worth the effort to make it from I equals 0. I think we just modify the denominator so it's n plus 1. No. Weird. So if we want to force this to work for I equals 0, we have n plus 1 many sub-intervals. So I was thinking maybe we just do n plus 1 there, but then you never get to 1, and you do want the 1 there. Maybe you don't. Maybe that's my disconnect. Do we want the 1 there? For m is greater than 0, I think we do. Yeah, because you want that very last one there. But then what happens with our I? Our I only ever goes as high as n, so do we also want I plus 1? That might be how we get the upper versus lower. Because the lower might be just I and not I plus 1. So maybe I'm not that uncomfortable with this then. So maybe I shouldn't have erased my example so quickly. Do it with this. And we do our algorithm here by hand. You get 0 plus 1 over 5. I know I wrote 0 plus 1 and then wrote 5 there, but it's fine. This will get you so yeah, n equals 4, we have n plus 1 many sub. That kind of breaks my brain a bit. So we're gonna get the first. I mean, I kind of hate that. This means we have to need n plus 1 there. I kind of want to. I just kind of want to define it for myself from I equals 0 to n. I feel like it's just so much cleaner. I don't know. I maybe I should ask Zach about that. But I hate having all the plus ones here. It just makes the formula look ugly. There's nothing wrong with it. It just doesn't look as nice. So if I go against advice here, I just think this looks nicer, I guess. So you have the first quarter of the interval now, times 4 plus -2. So, oh wait, if your m is negative, does this actually fix itself? Check chat. Okay, we're good. No, I don't think it does. No. I think we do need to split our cases for the sign of m. So what would that get you? It would get you to -1, which is what you want for a positive slope. But I was thinking if you had a negative slope where you had like a negative sign out there, I was wondering if this minus sign might save the calculation over here and fix it. But if you were to take that minus sign out and pretend you have a positive slope, that would get you to +1, right? With a positive slope. So like we'd be taking this case and basically flipping it. So it's like that case. But then the +1 doesn't make any sense. Unless they're doing it backwards. No, I don't think that's right. See, it seems to me that we do have to split it up based off positive and negative slope. Okay. And for positive slope, I'm comfortable that this is right. Up to 6 first, nice. Check if it's activated. I'm getting better about remembering to do that. I need to program it in to me to make sure that StreamerBot is running every time I stream. All right, so now the technique, we multiply the m inside here, and we need to do some summation tricks, basically. So the index here is I. So anything that's not I, we can potentially bring outside of the summation or into its own summation, depending on your persuasion or how the actual math is. So actually, no, let's do things a bit more, but yeah. Let me not do too many steps in one go. So the first thing I'm going to do is split the summation up into 2 based on that plus sign, which you're allowed to do, because if you're adding 2 things inside a summation like that, you can do 2 separate summations and add them after. Get the same thing. We do need to make sure we distribute that beta minus alpha over n though. Okay, so we get this, we can bring out everything except for the I. So the m over n and the beta minus alpha can all go out front. So beta minus alpha times beta minus alpha is beta minus alpha squared. We still have the m, and then over n is over n squared. Just I now, plus coming over here. If you sum MA many times, it's MA times n. Or sorry, if you sum MA with itself n many times, it's MA times n. When I say A, I mean alpha. We get the cancellation of the n's there, which is good, I think. That we can use Gauss's sum to figure out if you sum I from I equals 1 to n. Do you have a formula for that? One half n plus 1. The n's here cancel, so we get m. Alpha beta minus alpha. You can cancel an n with an n. The 2 in the n. I don't think I'm forgetting anything. Then over here, it's already simplified. Oh, we should get a common denominator though. Yeah, that's what we want here. Well, you don't have to. You probably. I think it's better if you do. M alpha beta minus alpha 2n. That's supposed to be n. Not implying anything, but I think the price of inside is reduced at the moment. Wait, the price of inside? Sorry, it's been a minute since I checked chat, so I forgot what we were saying before. $7.99 out of 1,000. Yes, the game inside. I saw it. I added it to my wishlist. I saw like, oh, the game's only like $2 or something. Yeah, I mean, it's like literally $2 or $3. I should just buy it. I'm gonna write another note to now buy inside, because I remember, I don't know why I didn't just buy it when I saw it was that cheap. Okay. So we have a common denominator. There's an n there and n there, so those are gonna be the like terms. We're gonna have beta minus alpha squared m plus 2m alpha beta minus alpha. Look. Let's see if I can do this all with mental math. Well, not all, but most. 2m alpha beta minus alpha n, and then that times 1 is our constant. Okay. Now as n gets very large, it's going to approach that over that, the leading coefficient over the leading coefficient. We can simplify the inside a bit though. So factor out a beta minus alpha that they have in common. Do you get a meaningful, you have a beta m minus alpha m, and you have a 2m alpha. So you get beta minus alpha, beta m, minus alpha m plus 2 alpha m is plus alpha m. n over 2n. That's supposed to be, oh yeah, no, that is m. Okay, can you even bring the m out from there? But either way, like, I don't know, I'm running out of room to write it. Oh, you want blue? Don't just buy it because you didn't imply anything? No. We'll do blue. I'm about to check my math here anyway. So in class, man, okay. I do want to make it look nicer. I just can't deal with it when it's like that. Beta minus alpha, beta plus alpha, and also you're messing with my color coordination sketchy, so I hope you appreciate it. I was gonna use blue just for things related to the initial problem, but now it's ruined. Okay, so we'd expect beta plus alpha. Ugh. Dude, that's too much writing. Too much writing. I just want to plug in the numbers that we were given in class. We had m equals a third, alpha equals 1, beta equals 4. Plug it in here. 1/3. Beta minus alpha is 3. Beta plus alpha is 5 over 2. And we get 5 over 2? That's the right answer. Okay, hell yeah. I was able to verify that formula. Technically, we should verify it with... Should do a separate calculation with a negative alpha and potentially like negative beta too, but meh. Now, of course, that's only half the answer because this is for m greater than 0. I mean, that's not even... It is half of like a quarter of the answer. This takes a lot more computation than I thought. I think we're going to only consider m greater than 0 for the sake of this problem, and m less than 0 is an exercise left to the reader, because it should be the same result and basically the same calculations. Okay, because I do want to go through and do the lower version so we can actually do the subtraction. Hey, Candido Robles. How do you get good at math? You do it a lot, unfortunately. You have to be okay with being bad at the start and just power through it and keep getting that repetition in. Basically like working out, I guess. You start out with light weights and you work your way up. And that one statistic question with 6 unique non-alcoholic drinks and then 2 people? Yeah. I hope I told you right. Oh, did you accept that redeem Spectry? I don't mind if you did. Notice that the request queue is empty. Unless I already accepted it. I don't know. Oh, okay. All right. Well, hey, that saves me work. I was right and you missed out on some points. Well, you know, never doubt me again, Spectry. I'm never wrong. That's the moral story there. Oh, someone posted a question in my Discord. Shoot, okay. Let me take a look at it. If you ever post a question in my Discord and I don't get back to you immediately, please type something in chat. 'Cause I'm not always able to check my Discord on stream. Or I do make an effort to like check it periodically, but I don't check it as often. I check like Twitch chat. So it says Fourier series, which I can't say I remember very well at all. So I think to find the Fourier transform of this, Hey, Geometry Dash music. How's it going? I'll try to Google it quickly and see if I can remember it, but I'm not sure I'm going to be able to help you with this. And I'll type back to this person in case they're not actually watching the stream. It's good to hear. What's the question? Proshtu? I don't know how you're supposed to pronounce it. Either way, thank you for the follow. What is e to the I pi? -1. Do you want to know why? Or I guess Dear Candida from YouTube. Oh, okay. Thanks for coming over on the Twitch end too. It depends how you define mathematician. I majored in applied math. With a bachelor's, so I'm not like a professor or anything like that, but I enjoy, you know, like tutoring others. Hey, Stooky, how's it going? All right, shoot. So this Fourier series person, I'm not sure I'm gonna be able to help him. It's been a minute for me. I might give a shout out to Mary. I'm not sure the person is watching the stream either, so I'm gonna type back to them in Discord. Let me because I'll be able to answer Geometry Dash's question quickly about complex numbers. I'll go to that first, and then I'll see what I can do about this Fourier series business. But Geometry Dash, you asking about why e to the I pi is -1. I'll explain it quickly, I guess, over here in the corner. E to the I pi. So if you know Euler's identity, shoot, I wish I had a bit more space. Euler's identity is e to the I theta equals cosine theta plus I sine theta. Parentheses. So if you have e to the I pi, you plug in pi for theta. So e to the I pi is cosine pi plus I sine pi. If you know your unit circle, cosine of pi is -1. Sine of pi is 0. So -1 plus 0i is just -1. So that's why e to the I pi is -1, basically. Yeah, Stuki, it's posted in my Discord. In the math homework help section here. So I assume it's to find the Fourier transform for this. It's been so long since I've done this though that I'm not sure I'll be able to do it. No worries at all, Geometry Dash music. Yeah, it's surprisingly simple. It can get hard, but for something like that, it's just, you know, 2 or 3 lines. So if you have any thoughts on that, Suki, I would love to hear them. Otherwise, it's gonna be me like umming and going to Google, or just saying try asking Mary. But why math in a deep level? I just kind of liked it. When I initially applied as an engineering major because I have a lot of engineers in my family, but I kind of took a calculus class and really liked it. So I was like, oh, let's just study math. That was way more difficult. Oh yeah, I mean, I don't mind answering simple questions either, but I sometimes have the same fear about complex numbers where I think it's going to be something ridiculously hard, and then it turns out to not be that hard. Because I don't have a very good intuition for complex numbers, or I'm still like building my intuition. This may be a better way to like phrase it. So we have basically a sawtooth, I think. Like a triangle wave, I guess, if we're going to use the terms from here. All right. Well, CHG Geometry Dash, thanks for the question. Smashing through definitions of the plan. If you can find the complex exponential formulas, I always think those are easier to compute. Oh, okay. And the sine cosine one? I wonder what... Oh, man. Even when I did learn Fourier series, it was really brief. I don't remember ever using the complex form for myself, which I probably could figure it out. But I guess let's just see what the definition is with sines and cosines first, and then worry about it. Okay. Oh yeah. So you already have like the formula already gives you most of what you need. You just need to figure out your constants, right? Like that's the entire problem. A0, AN, and BN. Hey, Bio. The period of this one is 2, because we're going from -1 to 1 RTs. Okay. This cleft sentence in English? I don't know what a cleft sentence is, but yeah, you definitely piques Stuki's interest. I know they like, you know, language or linguistics, so. Did we made it math or discovered it? It's kind of a philosophical thing, I guess. I think math as we know it, we invented because it might not be perfect. Maybe there is some type of perfect math that is, I mean, I think it was just invented. The universe just does what it does. And math is how humans try and predict it, I guess. These men are totally ruthless, and you're supposed to use the word what and turn it into cleft sentence. I haven't heard the term cleft sentence. Oh. These men are totally ruthless. Use the word what and turn it... Use the word what and turn it into a cleft sentence. It's hard to get the word what in there. We could follow like this format, like if I was ignoring the what part of that, I'd say it's these men that are totally ruthless. But if we have to shoehorn the word what in there, yeah. Oh, what Mary Bell was the first edition? Pseudo-cleft. Would it be like, what ruthless men? Right, right? Or what totally ruthless men? Maybe that's it? Like, sounds right to you, it should be right? I don't know. But these men are as totally ruthless? Oh, yeah, I misread it the first time. It could be that. Dude, I never learned this, and I had to do a lot of grammar as a kid. Why are there two different pop-ups on this site? Oh my god. It's already annoying to have one pop-up. What these men are is totally ruthless. Yeah, I think I'd go with what Stuki said there. I definitely can't come up with a better thing. So we do, I think we're working with an even function. No worries, Bio. Do we have... Oh, good. We have formulae for all of these. Okay. Well, I mean, if it's just doing this integration, I can definitely do that. Oh, I guess you're taking this and making it periodic? You're gonna get some integration by parts, I guess, which isn't the worst thing in the world. So let me actually type back to this person first. Okay. Okay. So okay, let me take a screenshot of the stuff I have on the whiteboard for real analysis, and then I'm gonna erase it, because we're gonna need a lot of space for this Fourier series problem. Just give me 1 minute. Oh, I probably need to, actually show my whiteboard, don't I? Let me take a screenshot of it. Snipping tool. Okay, there. Get rid of that tab. Okay. Let me get the... the image up on the board or up on the screen. Wait, what does capital T equal 2 mean? Oh, that's the period. Okay. You know, actually, let me just look at the definitions again. Do you need the actual period as part of these, or are they just giving you extra information for fun? I think it's just extra information for fun. Which is fine. Okay. All right. Well, it's gonna be my first Fourier transform in years, so hopefully we do it right. Oh, and I can see why doing it with a complex sine and cosine might be easier, depending on your function at least. I think just for the sake of familiarity for me, though, I'll do it with trig, even if it's potentially more work. Here, it might actually be, you still have to do integration by parts anyway, so it might not save that much time. Okay. So, f of t is a piecewise function, 3t plus 3. -1 is less than or equal to t is less than or equal to 0. Or equal, no, not strict. Or it is strict. Then minus 3t plus 3 over 0. Right? Right. Okay. And just a quick sanity check, if you plug in 0 to each of these, they do both equal 3, so... Oh! Got a raid? Oh gosh, Zach, thank you so much. We'll welcome in everyone. Hope that the rest of your stream was good. I'm about to do, wow, you guys came at like the exact time that I wouldn't want someone here. This is, I had someone ask me to find the Fourier transform of a function. This is the first one I'm gonna have done in years. It looks like it's just applying a formula and doing some integration though. So I think I'll be able to handle it, but I guess we'll find out. Reading for math is so strange, like here in Brazil, it's so different. Oh, yeah, there's always some differences in how different countries will note things. Oh, ooh, do we have to do, oh gosh, okay, wait, I'm already, since we have a piecewise function, do we have to do 6 integrals? Is that what's happening here? I didn't even think, it's like in this example, you have a continuous function, or you have a, sorry, not necessarily continuity, it's not piecewise. But if you do have a piecewise function, do you need to integrate each piece of it? I think you do. So you do from -1 to 0 and then from 0 to 1, and that's your a sub n? I wish they gave a piecewise example. Does Wolfram give a piecewise example? I don't think Wolfram gives, like, I never like Wolfram's explanations, to be honest. I don't know why I'm looking at it. Split the integral to 2? Okay, that's what I thought. All right, we can do that. It's just going to be, I guess, even more work. Oh, yeah. I'll bring the problem back up in a second here. It'll be -1 to 0 and 0 to 1, I think. Okay. We have even more work to do here. Hey, Ali. How's it going? Oh, shoot. You know, I need to see the formulas, too. Let me just take away the browser entirely. Okay. So, thank you for the follow. Ooh, turn off the cam. Okay. Hi, too. I go live Tuesdays, Thursdays, and Saturdays, starting an hour and 20 minutes ago or so. So factor out of 3. A triangle wave. Yeah, is there a trick for a triangle wave? Or I assume we still need to do it. With 2 integrals. Just copying in the formulas. N T pi over L. Wait, what is L2? It's essentially absolute value of x, but you still have to split that up to integrate it, don't you? L is half the period. Oh, okay. So L is 1. Ali, I don't think you can solve that with algebra. I think you have to do a numerical method. When you have an ln and a just x on the outside of it, you usually can't solve that, I think. Cosine series or sine series or both? Don't you need both? Okay, well, before I get too much in the weeds, first off, Ollie, to your question, I'm pretty sure it's impossible. It's not possible to solve algebraically, but let's confirm that. 1/5 x plus 3/5 equals ln x. No, Wolframalpha can only calculate numerically. You can't like do any manipulations to isolate x here. Okay, and then for the Fourier series, I'll give you all the context that I have. It's just Fourier series, and I'm stuck on this problem, so I can ask them for more information. It's even, so we can get away with cosine only? Oh, that's nice. Do you know assembly, bro? I took a class in it years ago. I've forgotten basically all of it, though. So if it's an even function, the sign becomes 0? I mean, that saves a lot of work. I'll take you guys at your word on that, because I wouldn't know for myself. Okay. But yeah, that's the context that I'm working with right now. Does this like say that? If it's functions are orthogonal? I don't if for the sake of this problem I only have to do the cosine part of the formula, I'll just take that as a W, I guess. Okay, so I was copying down. L is half the period. Do you know any programming languages? A bit of Java, a bit of C++, a tiny bit of Python. My programming is not strong, though. Okay. So L, the period is 2, so L is 1. So we have mt pi dt, and I'm calling b sub n 0 based off your guys' word here, which I'm okay with doing. Wait, if it's even, the sign part is 0? Okay, I'm not going to question that for now. Let's just give the person their answer. Maybe I'll look into it more after. Okay, so a sub 0, L is 1, so we get 1/2 integral minus 1 to 0, the upper part, 3t plus 3 dt plus 1/2 0 to 1 minus 3t plus 3 dt. This integral's not too bad. 1/2 to 0, it's 1/2. Okay, so that becomes, plug in 0 first. Those all become 0. Plug in -1, you get 3 over 4 minus 3 over 2. Plug in 1, you get minus 3 over 4 plus 3 over 2. 0 goes to 0. So setting, I think you'll be able to geometry your way into seeing, oh, okay. Should be an n. For a sub 0, there's no n, right? Yeah, for a sub n, there's an n term. For a sub 0, there isn't, or an n factor argument. I don't know. Something, words. Okay, so is that really 0? That feels weird, but maybe that's okay. I guess so. It's just what you get. L is 1, so we don't need to worry about that. Cosine. dt plus 0 to 1 minus 3t plus 3 cosine nt pi. So, integration by parts. Hey, Ben. Shouldn't A0 be the average of the function? Sine and cosine can't change that? No clue. Are you talking about maybe because it matches the format for the average value function? Does it? 1 over b minus a? It does kind of match the, well, I mean, yeah, should we get 0? Or should we get 1.5? Or no, maybe not 1.5. No, yeah, 1.5. I don't know. I get 0. Did I mess up a sign? Oh, wait. This comes from the lower bound, so this gets a giant minus sign in front of it. That one comes from the upper bound, so that one's okay. Okay. But then we don't get 1.5. Do we? That's 3/2 plus 3/2 is 3. Minus 3/4 minus... That's 3 minus 3/2 is 3/2. Oh, hey. Okay. That's a save, Jeff. And actually, since I remember to actually give out saves, Ian Stuckey definitely deserves a save. Oh, EnigmaBot might be asleep? Oh, no, okay, EnigmaBot's here. Also, Zach's been helping too. Okay. Okay. So. This is gonna suck. Well, no. Okay, we only have to do integration by parts. This is gonna be the same integration by parts for each of these integrals, so we can reuse our work here. Just one of them's gonna have a negative sign slapped in front. Okay. Let's take u equals 3t, dv equals cosine. No. Oh yeah, we have to. T pi dt. Derive u, we get du equals 3 dt, v equals integrate cosine to positive sign, divide by the factor. Okay, apply uv minus v du. 3t over n pi cosine nt pi minus v du, 3 over n pi sine nt pi dt. Okay. 3t over n pi cosine nt pi. Sine integrates to negative cosine, so that turns into a plus. We divide by the coefficients there, so we get 3 over n squared pi squared cosine nt pi. Okay. So this is going to be the result for 3t times cosine nt pi, and the negative of this will be for negative 3t times cosine nt pi. So we're going to have to come over there, make some squiggly arrows. So I'm going to do a lot of this. This is an annoying amount of things to write out. I'm going to mentally do 3t times cosine nt pi and just write out this result here. Actually, can we combine these terms? We could factor out the cosine. Really? We get the same cosine? Wait. Okay, yeah, I was like, that doesn't make any sense. That should... I made that sign, but I just wrote it as cosine. I hope there's Fourier transform calculator so I can check my work. I bet that Wolfram could do it. Okay, so yeah, we can't really simplify that meaningfully. Okay, so 3t times cosine nt pi, and I'm going to integrate that in one step and just write this out. N pi sine nt pi plus 3 over n squared pi squared. Wait, yeah, cosine. Plus, now we do 3 times cosine nt pi integrated. Cosine integrates to positive sign, divide by the coefficients. So 3 over n, that's pi, not n. And we said that's cosine, which will integrate to sine. T pi, all divided from -1 to 0, okay? Now we need to add in that integral. Should have new in chat, all right. Plus, now we get the same thing, minus 3t cosine n t pi, so we'll take this same result and slap a negative sign on it. That should be pi. Yeah, it is pi. I just can't write. I don't want writing nt pi. I'd rather like pi nt or something, but let's not break from tradition now. Okay, now we do 3 cosine nt pi. It's actually just the same as over there. Plus 3 over pi n sine nt pi. All of this from 0 to 1. Okay. It's the hard part done. Now we just got to plug in some numbers here. So this, starting with 0, that becomes 0. We get something from there, because cosine of 0 is 1, so we get 3 over n squared pi squared. That sine of 0 is 0, so we don't get anything else. So minus, now plug in our lower bound, -1. So we get a -1 out front, and we get a sign of a negative number. Sign of a negative number is the same as negative sign of that positive number. So the negatives are, we can pull the negative out front, and it's gonna multiply it to +1 with the -1 there, so get 3 over n pi sine n pi plus cosine of negative. Wait, can we say something about sine n pi if n is an integer? N should be an integer, right? Should that be 0? Yeah, n's an integer. From 1 to infinity. So, I mean, we can do the next step, I guess. I think it's going to turn out to be 0, though. This one, 3 over n squared pi squared. We get cosine of negative n pi, and since cosine is even, you can just ignore the negative sign on the inside because it's symmetric. So you get cosine n pi. Okay. Oh wait, I didn't do that. We have the same rationale here. No, we have a negative sign here. Because that one has a t, this one doesn't. Okay, now we're good. Okay, now we have to do this one from 0 to 1. Well, the good news is, actually no, we have to start with 1. 3 over n pi sine n pi plus 3 over n squared pi squared cosine n pi plus 3 over pi n sine n pi, close parentheses. No, close parentheses there. Okay. Now for 0, that's 0, that's not 0, that's 0. So the only thing that wasn't 0 was this. Oh god, it's minus that, so you actually get a plus. Cosine of 0 is 1, so you get 3 over n squared pi squared. I hope I didn't mess something up here. I don't think I did, but it's possible that I did. I got a bunch of pi squareds, Jeff. It's because it's because of the integration by parts. You get a pi, 1 over pi there when you do when you integrate dv, and then you get another 1 over pi when you integrate again for vdu. So we'll check out against Wolframalpha at the end here, but we're almost at the end, I think. So 3n squared pi squared, 3n squared pi squared is 6n squared pi squared. Sine of n pi, when n is an integer, is always 0. Because sine of 0 is 0. Actually, we didn't, n starts at 1, I guess. Sine of pi is 0, sine of 2 pi is 0, sine of 3 pi is 0, so that zeroes out. Cosine of n pi is either 1 or -1. So we can't... We should keep it as cosine n pi, I guess. You can maybe make a -1 to the power of n, if you wanted to go that way. Probably, I don't know what's more common to do here. There's a minus sign in front. Then we get that sine of n pi is 0 for the same logic. Okay, so we only get that cosine term. Now working on this line, sine n pi is 0, cosine n pi is just cosine n pi. There's the minus sign in front there. Sine n pi is 0. That we already dealt with. Okay. You could write it like in kind of a more fun way. Like that, I think? Right? So when n is 1, you get 2. When n is 2, you get 0. Let's see if this is right. You don't know what you're talking about? Okay. Well, neither do I, to be fair. Hey, SPQ. Let's see if Wolframalpha can do a Fourier transform. How do you do a piecewise? Well, okay. Just Google it. Hey, Henrik. Oh. How do you give it a piecewise function? Does sine make sense with that though? Just does sine alternate? I just want to see what Wolframalpha tells me, to be honest. If I can figure out, like, oh, you can literally just type in piecewise function and it'll tell you how to do it. Piecewise value 1, condition 1. So those are square brackets, it seems. Three over two, Zach, yeah. I don't know if the transform variable is particularly important. I'm called W, like Wolframalpha did. And then in here is where we do our piecewise input, I guess. Piecewise. We need some curly braces. I hate that it kicks the cursor out to the very end every time. Type that into Desmos. Oh. Oh. I think I did it right. Did I? Shoot, how do you do... No, how do you do piecewise function in Desmos? I forgot. 3t plus 3... No. Oh my god. You do the curly braces. Oh yeah, okay, so you do the condition first, colon the function. Okay. Kind of annoying. So condition, -1 less, no. -1 less than x, less than t, less than x, less than 0, colon 3x plus 3. Then can I do another one just right on the other end of it? 0 is less than or equal to x is less than 1, colon minus 3x plus 3. Does it like that? It doesn't like that. I don't know. Do a comma? Let's try a comma. Aha, got it. Is a comma? Okay. Thank you, Zach. Okay, it matches. Well, oh yeah, okay, it doesn't look exact right because we can't do infinitely many terms. But that looks pretty dang good to me. Yeah, if you do 100, it looks even better. Okay, that's kind of cool. I actually did a Fourier transform. I don't know how I didn't make more algebra or arithmetic mistakes. Oh yeah, okay. How am I going to express this to this person now? Um, solve for a sub 0. How do you make this so it's not like small? Do you double tap? Do you... Okay, there we go. You have to do the integral. You have to do following. A sub 0 equals... Oh god, I haven't written integral in LaTeX in a minute. Where's my cheat sheet? I think it's just like /int. Yeah, okay. /int underscore? -1 caret 0. We need a 1/2 in front of this too. (3t plus t dt) /frac 1 2 plus /frac 1 2 /int 0 caret curly brace 1 minus 3t plus 3 dt. And to get, wait, why is this italicized? Oh, because of the underscore? That's gonna mess up the LaTeX though, isn't it? I'll post it and edit it after if I have to. Oh, really? SPQ? It's like /int after the underscore limits? Oh, no, before the underscore. I can't read. Oh, well, are they going to be offset if you don't have the / limits? Like it's not going to rate them like vertically up and down? Okay. Oh, yeah, we don't have a coefficient here. /int /limits underscore -1 to 0 3t plus 3 cosine n/pi t dt. Hey, corrupt converter, how's it going? Plus /int /limits underscore. Oh, I forgot the caret. 0 caret 1 minus 3t plus 3 cosine n /pi t dt. Is that right? Oh, I forgot my oh no, I remember the cosine. Okay, let's see if that LaTeX works out. Discord might be messing with the formatting though. Let's see. Oh, did I do LaTeX right in the first try? Dude, I actually did LaTeX right in the first try, I think. Let's go. Let me get a screenshot of my work for this person too, and I'm gonna post that. The actual like board. Give me 1 second. Oh, don't go there. No, no. What did I do? Oh God. Okay, I'm good. Oh wait, this isn't good. Okay, got my screenshot. Okay. Should thing multiplied by a cosine. I didn't actually write the series. 1 over 0.11 is? I don't know why I wouldn't know that. So Jeff, like I didn't put the final answer. Which is probably a good idea to do. But the thing that I got for a sub n does get multiplied by cosine. Really? That's weird. Oh, shoot. That's what you mean, Jeff. I think you're right. I was misinterpreting your question. I didn't put the parentheses here. Okay, well, I technically formatted the LaTeX right, but I... Oh, okay. Well, I guess I don't know why I'm still typing them. Let me know if you have any questions in that case. If we were to type in the Discord or in chat, I guess. Okay. Sounds good. Okay, so I don't think there's anyone else in chat who's asked a question, or if you have, I missed you, please remind me. Well, hey, that was kind of fun. We got to remember what Fourier series are like. Oh yeah, I do want to see like, so an even function doesn't have a b sub n term, or the b sub n is 0. I guess that makes sense. And if it's neither even nor odd, then you have both of them. Because cosine can take care of anything that's even. Okay, let's let's go over to Desmos. I just want to see -1 less than x less than 0. Why am I bothering to copy that? 3x plus 3 sine. Wait, is that even how that works? Like, if I just say like sine of pi x, am I gonna get something that will make sense? I don't know if this is the exact right representation, but I guess you can see like, because I'm leaving off the n, but I guess no matter, I assume a value for n here isn't going to affect, you still get the same symmetry, no matter what your n is. Ooh. Whoa. That could make a cool graphic right there. Like, I could see this on a loading screen of a video game to get the pacing right. Oh, is it doing like an integer conversion, I guess? Hmm. Yeah, I assume Wolframalpha is doing the math right. It's just misinterpreting your input. Okay, so I guess that's why if the irregular function is even, your Fourier transform doesn't need to worry about the sign part. And I assume vice versa, if it's odd and it's neither, then you do need both. That's kind of neat. Okay. Yeah, correct converter. I think that's something like a programmer would do, and not a mathematician. And you know, Wolframalpha is made by programmers, and I assume and mathematicians too. But the person who programmed it probably did it for that reason. Integer and float conversion. That's what I mean. I guess I'm kind of talking out of my ass here. That is fair. I'm just like guessing. Really? Okay, so over 0.11. Yeah, why does that give 9? Wait. That's so weird. Wolfram's converter is corrupt? Maybe, yeah. I wish if I had Wolframalpha Pro, I wonder if there'd be another step after this. But they say the answer here is 9.09, and then the result, they chop it off. So I don't know. But there's no way in hell I'm paying for Wolframalpha Pro. Sig figs? It could be sig figs, yeah. Well, no, oh, yeah, you're right. Yeah, I guess it could be sig figs. Oh, yeah, that's a good way to test it. Actually, even if you take off that one, really? Yeah, why does it give you 9 as the result? Even if you give it... What? Yeah, I don't know. That's super weird. Yeah, math is a lie. Could this be base 9 or so? Or no, it wouldn't be base 9. That doesn't make any sense. Here's the answer. The correct answer is just 599 away. Yep. Yeah, I don't know. Wolfram doing Wolfram things. Multiply that by 1. Yeah, and then I'm sure we'll get just 9. Like you're saying, yeah. I don't know. Maybe things, yeah. For a real mathematician, they give you the real answer, but they think you only deserve the truncated answer. I don't know. Yeah, I can't explain that besides whoever programmed this treating this input too much like a programmer rather than like the user. But I don't really know. It might be some other explanation, like SPQ was saying. Who knows? Tessarines? I never heard of that. That sounds like a tesseract and a tangerine combined. Can ask Penn Center to grow that in his garden. A bicomplex numbers? Oh, it's a pair of two complex numbers. Huh. No, yeah, I've never seen these before in my life. One ijk, I squared is -1, j squared is +1, and k is ij. Huh. Now, I want to say that means k equals I, right? But maybe there's some more depth there that I'm not aware of. Because -I exists too, so j can technically be 1 or -I. And that's why it's not so easy. I don't know. Yeah, I mean, I'm not even that comfortable with regular complex variables, so I don't know if I would, I'm definitely like, I don't have the foundation to really look into those, but I'm sure there's some cool things that you can do with them. 2 minutes to answer someone's question. Oh, okay, nice. All right, so I don't think we have any other questions. Oh, wait. Someone... Oh gosh, we have another Fourier series one I just noticed in my Discord. Well, let's see. I guess it's a Fourier series kind of day. I discovered your channel, searching for tutorials on this. I've been stuck with this problem for a while now. So you have to do the Fourier transform of this? Would Fourier series be hand in hand with spectrographs? Oh, I have no idea, PhD. I think we could... spectrogram, sound wave stuff. Oh yeah, I mean anything that's periodic, a Fourier series transform could be involved. So to figure out, I'd start by looking for just one period of the function. We can take from -1 is less than t is less than 1, since it seems to repeat itself to the left and right after that. So we go from -1 down to -2. How do you make a piecewise function in LaTeX? Yeah, Peachy, I'm happy to like look into it a bit more too. I'm just not that familiar with Fourier transforms, to be honest. I learned a little bit in school, and then I forgot most of that. And then we had 2 different people come in today asking about them, so I've been trying to remember. First, for -1 is less than t is less than 0, just have a line starting at -1, 0, and ending at 0, -2. So we can say the function is -2t -2. Does that fit the bill? No, it doesn't. -1/2 t? Because rise over run. We run 1, run down 2. Hey, Cruz. How's it going? At 1, 2, so we can say it's 1/2 t. We found that it's a piecewise function. Is this odd? No, it's not odd. Okay. It's definitely not even. I can tell you that much. Down the piecewise function that defines, you know, this one period from -1 to 1, and can the formulas for A0, AN, and BN. Just the thing to be careful with is that the integrals have to be split up according to the piecewise function. So each one will need one integral from -1 to 0, plus another integral from 0 to 1. Okay. Let's see how that treats them. Or let's see if that makes sense. A lot of gasping happening. Oh, that's how you do it in LaTeX SPQ? All right. Thank you. So I guess I want to hear from this person if it makes sense. What's this here? Oh, the properties of tesserines? Okay. Yeah, what's up, Cruz? Oh wait, I was thinking about J is 1 or -1, not freaking 1 or negative I or whatever I said before. Oh, um, does this one say like the kinds of symmetry? Ugh. The points of the graph going up and down, like where it's increasing and decreasing? Oh, stop. The points where the graph changes, like where it's positive and negative? I guess, maybe like a translation. Oh, inflection points for double prime. Okay. Yeah, we can do that for sure. Just let me keep on helping this person first. And then once I know this person, I'll look at yours. Okay, half wave. is inverted about the horizontal axis. This... Yeah, this might be half wave here. Oh, that's the trick. So do you get maybe the same constant twice? The average value of the signal is 0. So a sub 0 is 0. Order wave symmetry too. Wow, okay. I'm pretty sure this is half wave though. It does seem to be half wave. Some special formulas are a bit simpler. Because it's basically the same thing, it's just flipped on the horizontal axis like they were saying, I think. Is equal to minus f of t minus t over 2. And here, t is the period, t is 2. So f of t is equal to negative f of t minus 1. So at t equals 1, we get 2. And then f of t minus t over 2 is f of t minus 1. So at 0, and you get negative, so negative 2. Yeah, so it's definitely half wave. Okay. I'm not sure. I'm ignoring that part, PhD. I think the vertical lines in general you can just completely ignore when doing this, I think. Because x equals 1 or whatever isn't a function, like you can't really integrate that. Of course, you can, but it's 0. The Lube69 server? It is a publicly available server, I guess, but it's just a friend's Discord, basically. It's nothing that perverse. Do from there? No, I'm not gonna go do it on stream. There's nothing bad in it, I just don't want to show someone else's Discord. How about this? I can shout out the person whose Discord it is, and you can go and join it through their link if you want to see it that bad. It's actually a few people's, but Donkey. He's one of the people who has that Discord server. You want to see some lube? Well, there you go. That'd be so big where you have to come to the W door. Okay. I think that's halfway if I remember my Spanish right. Two n minus one? I assume that's right. Let me just see if that matches with the website. Seems a little weird to have 2n minus 1 there. I mean, the website that I'm looking at doesn't actually express it exactly like that. It's probably an equivalent thing. Yeah, I think it's equivalent. You won't actually have to do two separate integrals like I thought. You'll just have to do one each if you do those formulas. Okay. Oh gosh, that's a lot. I'm definitely I can't read all this right now. I don't know if I'm like I can't just take a lesson on tesserines right now. But I appreciate your enthusiasm for them. Okay, so Cruz, I don't want to keep you waiting for too much longer, so I'll switch back and forth between your question and this person's. But yeah, I'm sorry, you're gonna type an essay in my Discord, I just can't read it on stream. I appreciate it, but I can't read it right now. My main passion is helping people have homework questions, so unless things are really slow, I don't usually just read through stuff like that for fun. Oh my god, all right, this thing's getting sprayed. Okay. Oh my god, something still dropped. Okay. So let me think you got it right till here. Okay, so let's look at what you weren't expecting me to. Okay, I appreciate your understanding, corrupt. Sorry, because I feel bad that when you put like that much effort into it, but it's like it's hard to get everything done on stream. Okay, so it looks like I haven't heard back from Robert yet, so we have let's look at, or Robert might just be fine too. Okay, so yeah, we have x cubed minus 3x squared, just verifying the original question. And you need to find the inflection points. Why can't I zoom in on that? Okay, I just don't get to zoom in. That's fair. So your first quotient rule, derive the numerator first. You get 3x squared times the denominator, 3 minus x squared. The derivative of the denominator, that is negative 2x, so that turns into a plus 2x times x cubed. Okay, I agree with your first application of the quotient rule here. So you're saying it's equal to some constant times x squared minus x to the fourth? That is a true statement. Is this where you're, and then you're deriving it again over here? Is that what's happening? So you have 9x squared on top minus x to the fourth. Okay, yeah. So this looks like we're doing quotient rule again. God, this is such a pain of a function to do quotient rule with. There's no quotient rule that's easy though. They're all annoying. This is especially hard, like annoying though. So you derive the numerator again. 9x squared derives to 18x. Minus x to the fourth derives to minus 4x cubed. Did we try and find y equals 0? Yeah, okay. I'm just verifying the work before. It seems so far that you're doing it right though. 9x squared, so minus 9x squared minus x to the fourth, good. Minus, or times rather, the derivative of the denominator, which is going to be 2 times 3 minus x squared times negative 2x. Perfect. Over 3 minus x squared now to the fourth. So you factor 3 minus x squared out. That is perfectly valid and a good idea. Okay, good. You multiply out this here. Oh gosh, dude, that's a pain. Okay. So 18x times 3 is 54x. 18x times negative x squared is negative. Okay, yeah. Minus 4. Oh my gosh, okay. Plus 4x to the fifth. Okay, good. I agree with that. Minus, and then you multiply this out. 9x squared. This is negative 4x? Okay. So 9x squared times negative 4x is... Where does the minus sign go here? I think it's negative 36x cubed, and then plus x to the fourth. So I think you might be missing a minus sign there. Just make sure my cursor is showing up on stream. Okay. So yeah, I think you're missing a minus sign in front of the 36x cubed, and then, but everything else, I agree with so far. You factor an x out from everything, which seems reasonable. So many times it's not right. No, I agree with this. It's only, you need to put another minus sign in front of the 36x cubed, I think. And everything else, as far as I can tell, is right. So let's, I mean, I can work it out from where I agree with your work last, if you want to see that. So let's copy down. I guess I'll start with, I'm just gonna take the last line that, or I'm just gonna take the line where I saw an issue and make the edit. So we have 54x minus 18x cubed minus 12x cubed. Yeah, minus 12x cubed. Plus 4x to the fifth. Minus, and this is where I'm saying we don't want the minus negative 36x cubed. It's 4x, was that to the fourth? Okay. Two minus x squared cubed. Okay. 3 minus x squared. Ooh, thank you for that save. You're right. Okay, so now if we pick it up from here, we'll do what you did. Let's factor an x out from everything. We get 54 minus 30. X squared now, because we factored in x out. Just verifying it. Oh, okay, you didn't combine the 18 and the 12 yet. Like that, I think. Okay. So let's bring the highest degree term out front, just because I'd like to look at it when it's like that. We have a cubed. Squareds combine. We have no x to the 1s, do we? Interesting. That's not really factorable easily. Whoa. That's a mean problem. Let me verify that derivative, because there isn't an easy trick to factor this. You'd have to do some very long method. So let me actually go to Wolframalpha before I get too much deeper in the weeds. Oh, and actually, we can answer a quick question from Robert here. The period is 2. To 1, so we do 1 minus negative 1 equals 2. Okay. Let's d by dx Yeah, let's take it from the original problem here. X cubed over 3 minus x squared. So let's verify your first derivative first against Wolfram. Make sure, I'm pretty sure it was right, but let's not take that for granted. Oh, I think I caught that mistake. For that x cubed. But if there's another x cubed that I missed, please tell me. So Wolfram says it's basically 9x squared minus x to the fourth, which what you got, over 3 minus x squared squared. Okay, yeah, so Wolfram agrees with your first derivative. And also get the second derivative. Huh. What a weird way to give me the second derivative, Wolfram. Why would you do it like this, Wolfram? This is, okay, this is closer to how a human would write it. They got 4x squared minus 4x squared. Well, we didn't get nearly as many cancellations. I wonder if there's an algebra error somewhere in there? Because we just have way too many terms. So let me start from the first derivative and go to the second derivative on my, or like, without using your work. And let's see if I can get to the right answer. Actually, I'm not sure where you went wrong in your work. Because I thought I was following along with it, and I agreed with everything. Except for that one sign on that 36, but that's a pretty minor thing. All right, so if f prime of x is 9x squared minus x to the fourth over 3 minus x squared squared. Let's make sure that's right. 9x squared minus x to the fourth over 3 minus x squared squared. Okay. Oh, I think Wolfram gave me a decent looking form down below, Jeff, but thank you. Maybe some trick on this. Yeah, so I wonder if I just like do the problem fresh for myself, if I'll be able to arrange it and find an easier trick here. Okay, so f del prim. Start by deriving the numerator here. 18x minus 4x cubed times the denominator as it is minus, now the numerator as it is, 9x squared minus x to the fourth times the denominator derived, 2, 3 minus x squared. Now chain rule, minus 2x. To the fourth, okay. You know what, for so far I kind of actually like the way that you did it. Like, even when I approach it with like a fresh mind, I don't really... bring the minus 4x out front, and that turns into plus 4x. Then let's cancel 3 minus x squared. Just like you did. Now, yeah, we don't have a choice. Well, oh, there's another cancellation we can do here. Factor in x. No, there's not. Never mind. I'm dumb. I thought you could turn that 9 into a 3 and then factor out an x squared, but you can't. Never mind, never mind, never mind. Is there a different trick we could potentially do? Not really a helpful one. I guess we have to multiply things out. Okay, let's verify 18 times 3. Yeah, it's 54. I think so far I'm just following your work, same exact as you did it. Factor in x out with the highest degree first. Oh wait. Oh wait. The x to the fifths cancel. I don't think you got that cancellation in your work. Yeah, you gotta the exponent there might have been wrong in your work. So when you did this x to the fourth, you took this x to the fourth, you multiplied it by the 4, or the negative 4 that's here. You forgot the x though, that was right there. So this should be plus 4x to the fifth. And then a minus in front of that 36. So that makes the problem a little bit simpler. Once we realize that, I'll keep working it out. But that's a mistake that'll really make things a lot harder. Because now, really? Those are just gonna cancel. You know, add to 0. Oh yeah, and then we have 3 cubes. Negative 30 plus 36 is plus 6x squared. Okay. That's much simpler to work with. And now we remember we're looking for inflection points. So the entire time we've been intending to set our second derivative equal to 0 because that's how you find inflection points. So we can now remember that this thing is equal to 0. The only way for this thing over here to be equal to 0 is if the numerator is 0. If you have 0 in the denominator, then it doesn't compute. You can't divide by 0. So we're allowed to just forget about the denominator entirely for the sake of this, of finding where it's equal to 0. So from here, we already get x equals 0. From there, we get 54 plus 6x squared equals 0. That's imaginary. Did I mess the sign up, or are we just not supposed to get... Maybe we're not supposed to get a solution here? I don't know. When you screw it each side, you're going to get an imaginary number, so... I guess we only get one inflection point, x equals 0. We should look at the graph and verify that, though. Square root 3? I think your friend may have made a mistake. Wolframalpha, this is the same answer that I got. Just looks a bit different. And not only that, let's plot the function and see if root 3 makes sense. I don't think it will. That was the original function, right? All right, right. Just scrolling up. So here at x equals 0, there's definitely an inflection point there. That makes sense. Square root 3 is 1 point something. 1.7? So over x equals 1.7, like nothing much is happening. There's actually, that's actually a vertical asymptote. You definitely don't have an inflection point there. Because square root 3 gives you 0 in the denominator if you plug in root 3 here. So that's definitely not an inflection point. The function isn't defined there. So yeah, this centerpiece of the function, I only expect it to have one inflection point looking at its graph. And these other two pieces up here and down here, they're always concave up or concave down, so I won't expect them to have inflection points either. So I think x equals 0 is the only solution is appropriate. Oh, so do you have to make a chart with like pluses and minuses? Because in that case, it is valid to use root 3. It's just, it isn't an inflection point. Okay, let me actually show you what I'm thinking you might have to do, and you tell me if that's what you're supposed to do or not. So in some calculus classes, they make you do what are called sign charts. You have to do something like, let's say minus root 3, 0, and root 3. And then you have to think about the concavity on each part of this. So past negative root 3, we said it was concave up. Between negative root 3 and 0, remembering the plot of the graph, you can also plug into the formula here. Example values, but just I'm going off the graph. It was negative for the left middle. The right middle was concave up. And the right side after root 3 was concave down. Like you're supposed to make that. So I really don't know what exactly you mean by the what's plus and what's minus thing. There's a couple of different interpretations there. But, hey, Captain Jules. But the moral of the story is, plus and minus root 3 are not inflection points, but when you have rational functions, you do have to include the vertical asymptotes as points where you break up the function to look at increasing or decreasing, concavity, or actually positive or negative. Which are kind of the three different ways that I'm interpreting what you're saying, Cruz. Where f of x is positive and where f of x is negative? Okay. So like, the second derivative doesn't necessarily help you with that, but like just... If you want to find where f of x is greater than or less than 0, you have to find where it's equal to 0, which you'll just get x equals 0 again. And then you set up the same chart with minus root 3, 0, and plus root 3, and you plug in example values into the original function. If I didn't get to see the gang, oh yeah, welcome, Captain. So yeah, I remember seeing you in some other people's chats. It's good to have you here. Uh, 3i is not square root 3. So we did get imaginary numbers when we were trying to solve that second derivative equal to 0. But when you get an imaginary number, you throw it out completely. It doesn't mean anything for the sake of this problem. Wow, what is this song? It's kind of annoying, to be honest. So the reason root 3 is included here is because of the original function, not because of anything we did with derivatives. Derivatives, just look only at the original function, and you're not allowed to plug in square root 3 or negative square root 3 because of that denominator. That's the reason why we're talking about square root 3 at all. It's nothing to do with the derivatives. It's only to do with where the original function is defined. Although it comes up for the derivatives too, the reason why we're talking about it though is because of the original function. Someone asked a question about a property of complex conjugates. We have an equation you negate on instance of I. That's interesting, corrupt converter. Yeah, I wouldn't know the answer to that question if someone asked that to me. Well, that's where I think we're maybe having a translation issue, Cruz, or something, because I don't understand. I'm still a little struggling with the interpretation, I guess, but the function isn't defined at plus or minus square root 3, so it can't be positive or negative there. So it's not drawable at x equals plus or minus root 3. Everywhere else, you can say it's positive over here, negative in there, positive here, and then negative again over here. Like, you're allowed to say that. Just when x equals plus or minus root 3, you can't say much about it besides it's not defined there. Oh, that's funny, corrupt. You know them only in Hebrew. Oh, okay. Yeah, that would make it a lot harder. See, I'm sorry that I'm being so like, I can't tell you for sure, but that's because I feel like, yeah, like we're having a translation issue, I guess, where I don't want to tell you the wrong thing because I'm not sure that we're on the exact same page. If you have an asymptote, you can draw it. Yeah, so a lot of times people will do like a dotted line, like vertically, wherever there's those like breaks. That's how they like show a vertical asymptote. You don't have to technically, but that's how people will usually do it when I see it. I mean, well, Desmos even do that. X equals square root 3. Yeah, so they'll do like a vertical line like that. Can we make it? I don't know if we can make it dotted, but... So that's how people would usually... You can? Okay, I'm so bad with Desmos, dude. It's really unintuitive for me. I don't know. Long press the circle? Oh, dude, this is... I'm sorry, dude. Desmos is worse than Snapchat. Like, how am I supposed to figure that out on my own? Desmos is such a cool grapher tool. I have no idea how to use it because they just don't tell you, I feel like. Maybe I'm not paying attention, but like, I wish that was easier to figure out just by using it. It is a really cool site, and I like it a lot. It's just doing some of the finer things with it bends my mind. Yeah, I wish it was on this page though, I guess. Is why I'm complaining about this free thing that's being done for me. I just get annoyed easily, I guess. Yeah, you can do some crazy things. Someone showed me some super crazy, like cinematic made entirely in Desmos, like animations and all that stuff. Should I take for the up and down? Which... Okay, it's not eyes though. It's not I. It's square root 3. But if we're talking about... So do not do anything with imaginary numbers here. I need to emphasize that. There's no, like, for the sake of doing problems like this, if you get an imaginary number, you just ignore it. Like, we got an imaginary number here, we're ignoring that. So that's that chart I made for concavity involving f double prime of x. And the process you would do for the original function, like I'll just maybe say sine. It's kind of unclear what I'm saying with this. X. Let me write it like this. Okay, so I got these numbers again, or sorry, in these numbers, the 0 comes from the work we did over here to get x equals 0. The square root 3 comes from the original function right there, where you're not allowed to plug in plus or minus square root 3. No i's are involved here. If you plug in 3i or negative 3i, you get something else completely. But square root 3 and positive and minus square root 3 are the issue here. That's why we keep including them, because they're vertical asymptotes, and so the function changes behavior on either side of those vertical asymptotes, or at least it can change behavior, and you need to examine if it does. So when you make a chart like this, never use I, is the moral of the story. Now, if you're looking just at the original function and at values around its zeros and the vertical asymptotes, here, this 0 comes from the numerator being 0 when x equals 0. And these square root 3's come from the exact same place as the last time. So even though it's the same numbers, they do come from slightly, the 0 comes from a different place. The square root 3's are the same though. But yeah, to do this, you would plug in, like, to get like the sign for over here, if square root 3 is negative 1.7 something, just plug in like negative 2 or something that's certainly to the left. So you plug negative 2 in, you get negative 8 over 3 minus 4. So that's a negative over a negative, which is a positive. If you plug in, let's say negative 1 is between those next two, you get negative 1 over 3 minus 1 is a negative over a positive, which is a negative. Between 0 and the root 3, let's plug in positive 1. You get 1 on top over 3 minus 1. Positive over positive is positive. And then here, let's plug in positive 2. You get positive 8 over 3 minus 4. Positive over a negative is negative. And you do the same thing with f prime x as well, and that'll be increasing or decreasing. What do you call it? Oh, sure, I'm sorry, Cruz. I wasn't watching chat when you said that. If you can say what part that you're referring to, I'll try and go back and point it out. You once accidentally made this animation? Let's see. Whoa. Yeah, it is like the the arch in St. Louis. That's funny. What are these functions? L? Oh, L is over here. Okay, I thought L was some special function. Wow, that looks crazy. Wiggly revolvings. Gateway arch. Okay, yeah. X is not equal to plus or minus root 3. Oh shoot, so yeah, so for like, what do I call it? I'll write it down too, just because it... So we would call it a vertical asymptote. I think it's the answer to your question. Asymptote. X equals plus or minus square root 3. And that's because you take the denominator and figure out where it equals 0. Because we can't divide by 0, so anything that results in division by 0, the function is undefined. So you get a x squared equals 3, x equals plus or minus square root 3. And functions can change their behavior on either side of a vertical asymptote, so you always need to examine those when you're looking at the behavior of a function. So that's why no matter what we did here, we always include our vertical asymptotes as things to examine. because the function can change its behavior no matter what property we're looking at, whether it's concavity or the sign. And I didn't show it, but increasing or decreasing is another property that's often examined. But I want to actually like figure that one out unless you need to see it. But so yeah, I was trying to figure out like which one of those three things that you were talking about, the plus and minus thing. It sounds like you're asking the actual sign of the function though. But yeah, so like vertical means up and down, and that's why I drew these vertical lines here, because they just go up and down, and it's like the function can never touch these lines. It can get very close, but it can never quite touch. Oh yeah, and corrupt converter is saying like a separate issue that can happen where you can have a removable discontinuity or some other like punky situations, but x over x equals 0, yeah. So what I said is like the basics. There are some other weirder situations, but what is this? How do you use this? Do you play that? Oh. I don't know what this means, but this looks pretty amazing. You can move the red and black buttons on the graph. Oh. What? Oh, I might have dragged it out too far for. Oh no, I don't know. Or is there another last folder somewhere else? Conformal map of a complex function? Oh. Do you figure what the green is? Oh, okay. Yeah, dude, you can do so much in Desmos. I don't know how you like, I don't know how you do it, which is why I get frustrated at it, I guess. I know Desmos is super advanced. It's just, for me as like a casual user, it's always felt a little bit like unintuitive, but I do actually respect that you can do like crazy things with it. AR plus BI. GeoGebra? Oh, yeah. Hmm. I'm sure there's a whole like can of worms that's what this, but like it always kind of amazes me, like, are complex numbers a special case like of vectors, or is it the other way around, or do they only happen to look similar? Because these are just like unit vectors right here. Just I guess you have the extra property that I times I is -1, which makes things a bit different. Complex numbers is 2D points. 0.02% in math this year with its rounding. Not 0.02%. They aren't built in. Oh, okay. That makes it even harder, I guess. When you work with, oh, like x to a fractional power? I normally prefer the fraction. It's really a choice of style though, Cruz. Unless, like, if it's a square root, I'll just have the square root symbol. But other than that, I usually just use the fraction. The fraction notation is a bit, like, more flexible. So often if there's like a 1/3, there's also like a 5/3 in there or something else too. Was Jacobi am? Jacobi am instead of Jacobian? Oh, wow. Jacobi amplitude. Oh, okay. I haven't heard of that. Wait, I respect the hell out of people who can make stuff like that. I just know that I can't for myself. One of the biggest pains in my ass, I bet. Jacobi elliptic functions. I'm just debating what I want to do. No problem at all, Cruz. Glad that I was able to help, even though I was kind of a little confused at some points. And I'm sure that was confusing you too, but I'm glad that we got there in the end. All right, I won't wrap things up quite yet. Let's, because before we went on the train of Fourier analysis problems, I was working on this for the real analysis class. Oh no, I lost the screenshot that I took. Shoot. No, I don't want to redo all this work right now. I'm feeling a little like I'll look for like one or two like easy questions out on Reddit if someone else has posted, but I don't know if I'm gonna go for a ton longer. That does not look like an easy question. It might not be that bad, but I just don't want to read an essay right now. For the graphing on there, one of the first couple lines is a graphing complex function with the red grid as the input. Okay, yeah. Shape a rectangle grid plots through a function in the complex plane. It's fair enough. I honestly, I don't know exactly what that means, but because I'm not very experienced with the complex numbers, I guess. I only know like the very basics. W of t equals sine of 2t minus 3t. It's the equation relates to the water level in a tank at any given time t, which is hours past noon. Find the average water level in the interval from 1 p.m. to 6 p.m. Hours past noon, so yeah, from 1 to 6. 1 over 5. Makes sense to get a negative here, I think. They need to do the 1/5. Oh, they did do the 1/5. They were just... Let's verify the result of the integral, I guess, but I think that seems pretty reasonable to get a negative result. Imagine you drew a rectangle in the complex plane, add a bunch of grid lines into it, everything along those lines, you plug into a complex function and plot the output. Also, it's a way of not having to calculate literally every single value ever, just like restricting your domain, I guess. T greater than 0. Well, is that true? I think so. Yeah, I think it's true. A negative result by interpretation of the situation is that the water tank is gradually losing water, but fluctuating up and down a little bit as it loses water overall. Okay. Actually, I can even... The t equals 0, the t greater than 0 part is a little bit sketchy to me, because for 1 is less than t is less than 6. That's really all you need to know. You don't need to worry about between 0 and 1. But between 0 and 1, I don't know, sine might sometimes be greater than the line. I kind of doubt it, but I don't know that for sure, and I'm too lazy to open up Desmos and zoom in, I guess. Steepest slope of sine is 1. Oh! That's a nice way of thinking about it. Alright, well, I mean, my answer still applies, so I won't go back and edit it, but I guess we can... I guess I'll stop being lazy for half a second here. Oh yeah, that didn't even come close, dude. What the heck? Okay. I thought maybe there'd be a potential thing here, but I guess not. All right, I think I might wrap things up here. Is there anyone who's doing math? Oh dang. I usually try to hold out until I can raid someone, at least on Tuesdays and Thursdays. Oh wait, Alejandro's streaming. We could go raid Alejandro. I don't think I've raided him before. All right, I'm gonna end things over on YouTube. So if you're here on YouTube, I appreciate you. I'll be back on YouTube on Saturday with more math.